law of change in momentum. So let's consider we have the trajectory of a particle, and particle has mass m and instant velocity v. So then momentum is defined as a multiplication of mass and velocity, and because the velocity is a vector quantity, then p as a momentum must be vector quantity too. Mass is a scalar value. So v is a velocity, m is a mass of particle, and p is momentum. From this expression follows that if velocity has a physical unit meter per second and mass has physical unit kilograms, so momentum has physical unit kilograms per meter over second by. So we can make an association with second Newton's law. Which says that change of momentum in time is given by acting force. If we multiply this equation by element of time dt, we get this equation. F as a force by dt is equal to dp. So it's a differential equation, and we can add integration signs. So when time was, for example, time 1, t1, then momentum was some value, or that was a state of momentum in time 1. And if we consider that some process ends in time 2, so it will end with momentum at the state 2. So if we continue in this integration, we can write that f, what can be a function of time, f dt from t1 to time 2 is a q, and this is a difference of momentums in state 2 and in state 1. So this is the final formula. We can continue. It is equal m by v2 minus m by v1. This part, left side of equation, is called EIF, and it is impulse of force. So impulse of force is an integral f dt from t1 to t2. So we can say that impulse of force in time interval from t1 to t2 is a q to difference of momentum at the end of the process. So let's make short example. So if we have trajectory and particle at time 1 with constant mass m and velocity v1 at the beginning of the process, and during the process there acts some force F to the particle, and the process finish at time 2 and the particle has velocity 2. Okay, so and between in general position there is a particle m and there is some force F, what is a constant, for example. Okay, so if force is given some constant, we know velocity at the beginning of the process, so it is the initial velocity. We know mass of the particle, and we know time interval, so we know t2 minus t1. So what is an velocity? So final velocity. So we can write that integral from t1 to t2 f dt is equal m by v2 minus m by v1. It follows from this, okay? And because it is one axis, 1 degree of freedom system, so particle makes a rectilinear motion on some linear trajectory. So we can cancel vectors, so we can rewrite it to scalar form. From t1 to t2 f dt is equal m v2 minus m v1, and from that follows that v2 is equal f over m by t2 minus t1 plus v1.